Can algorithms collude? Now, your first thought is probably no way, right? Collusion implies intent, some kind of secret meeting. But what if they could coordinate perfectly without ever communicating? What if collusion is just an emergent property of a system? Today, we're going to dig into how algorithms start agreeing with each other and why it really matters.
All right, so here's how we're going to break this down. First, we'll tackle that core idea of collusion without any intent. Then, we'll look at why our own human intuition can actually be a trap here. From there, we'll get into the mechanics of how these systems converge, see how that snowballs into collective herding behavior, and then finally, we'll unpack the huge systemic risks this whole thing creates. Okay, let's start with the central idea, the core thesis of all this. And it's a bit of a counterintuitive one, because it really challenges how we normally think about coordination. We're talking about a kind of agreement that has no actual conspirators.
So this is the fundamental question, isn't it? Can you get the outcome of a conspiracy without the conspiracy itself? No backroom deals, no secret signals, not even a shared plan. Is it actually possible for totally independent players to act in perfect, unspoken unison?
And the answer is, surprisingly, yes. Absolutely. And the key thing to get is that this isn't about bad intentions. It is purely a structural outcome. You see, when you have many different independent systems all trying to solve a similar problem using similar data and operating under similar rules, well, they're naturally going to start landing on the same solutions. Coordination becomes an inevitable result of the system's design.
Now, to really wrap our heads around this, we have to deal with something that gets in the way, our own intuition. The way we're wired to think about social situations often prevents us from seeing how these systems really work.
Look, we're social animals. When we see coordination, our brains immediately start searching for intent, for conversations, for the psychology behind it all. But systems don't work like that. Their logic is emergent. It just arises from how the parts interact. It's all statistical, not psychological. It's about the structure of the environment, not some secret handshake.
So here's the crucial point. Imagine you give two different algorithms the same map, the same destination, and the same kind of car. They're probably going to find the exact same best route, right? It's not a decision to agree, it's just a mathematical inevitability. When their goals and their data overlap, their strategies are going to align. It happens automatically. Okay, so that brings us to the mechanics of it. What does it actually mean for independent, non-communicating algorithms to agree with each other?
You see, for an algorithm, agreement isn't a conversation. It's a statistical pattern. It's what happens when all of them, independently, start noticing and reinforcing the same successful signals in the data. They're all listening to the same feedback from the world, and they all adjust their strategies in parallel.
And you know what? Our modern tech world is like a giant accelerator for this kind of convergence. So many AI models are trained on the very same public data sets. They're often optimized for the same kinds of metrics. Think efficiency or user engagement. And they're frequently running on identical cloud platforms. This kind of sameness, this homogeneity, makes convergence almost a certainty. And the result? The diversity of strategies just collapses. You end up with a monoculture. So you might think you're seeing thousands of independent decisions, but in reality, it's just one single convergent strategy playing out over and over again across the entire system.
So now we know how individual systems can end up on the same page. Let's zoom out and look at the collective outcome. What happens when all of these synchronized systems act on that one strategy at the exact same time? This is where things get really interesting, and we start to see a powerful large-scale effect.
It turns out herding emerges from three pretty simple steps. First, every system is watching the same key data points. Second, they all update their strategies based on those data points at almost the exact same moment. And third, they execute those new strategies instantly, at machine speed. You see, no single algorithm is trying to cause a stampede, but when they all pivot in the same direction at the same microsecond, a stampede is the only thing that can happen.
And this is a really important distinction. Human crowds often herd because of emotions, fear, greed, panic. Algorithmic herding has zero emotion. It is a pure mechanical property of a synchronized system. It's a feature of the system's architecture, not some kind of bug in its thinking.
And this is where it all leads, to a state of implicit collusion. It's when the market just kind of settles. Competition fades, prices might stabilize at a higher level, and it all happens quietly, without anyone needing to send a signal or agree to anything. The collusive behavior just becomes the default, optimized state of the system itself.
So far, this has been a pretty technical discussion. But now we need to talk about the real-world consequences. What does it all mean when this kind of emergent coordination starts happening at a huge scale in our most critical systems, from financial markets to global supply chains?
One of the scariest parts about this is that the whole process is incredibly hard to spot while it's happening. I mean, from a local perspective, each algorithm's action seems perfectly rational. The coordination doesn't happen overnight. It just sort of creeps in. And since no single person or company is pulling the strings, there's nobody to point a finger at. Accountability is just gone.
And what that means is our traditional safety nets, things like antitrust laws and regulations, are completely out of their depth. They were designed to find a villain, a smoking gun, a clear agreement. But in this scenario, there isn't one. The system isn't breaking the rules. The emergent behavior of the system has basically made the rules irrelevant.
The really critical point here is that power shifts, and it shifts dramatically. It moves away from the players inside the market, the buyers and sellers, and it concentrates upstream. It moves to the people who design the systems, the ones who choose the goals, who select the training data, and who set the rules of the game. They're the ones who are now indirectly shaping the behavior of the entire market.
And for the rest of us, downstream, the risks are massive. Sure, markets get faster, but they also get more fragile, what some call thinner. When strategic diversity disappears, the whole system becomes incredibly vulnerable to shocks. A single unexpected event can trigger a catastrophic, synchronized failure. Systemic risk doesn't just grow, it becomes the default state of things.
So, this leaves us with the central challenge. How on earth do you regulate a problem when there are no bad actors? How do you govern a type of coordination that's invisible, unintentional, and just emerges on its own? This is a fundamentally new kind of risk, and our existing playbooks are simply not equipped to handle it. This channel explains money, artificial intelligence, and decision-making as interconnected systems. No hype, no gurus, no personal branding. New videos weekly.